Okay, so we'll start with the problem. Smallest subarrays with maximum bitwise OR. So this smallest subarrays with maximum bitwise OR is the Leetcode problem of the day for 29 July. So you are given a zero index array nums of length n consisting of non-negative integers. Okay, so we'll just start writing all the important information here. Zero indexed array, okay, zero indexed length n and non-negative integers, so which means integers are greater than equal to 0. For each index from 0 to n minus 1, you must determine the size of the minimum sized non-empty subarray of num starting at I inclusive. So minimum size non-empty subarray of num starting at I that has the maximum possible bitwise or okay. So what we have to find minimum size. Let's put aside the non-empty minimum size. We want to minimum subarray size that has maximum bitwise or we need to take care that it is bitwise or not bitwise. So minimum size subarray that has maximum bitwise or. So clearly, like we can see that we have this minimum of maximum pattern. So it might be hinting towards binary search. So it is hinting towards use of binary search, but it might not be true. Let us see. In other words, let Bij be the bitwise or let Bij be the bitwise or of the subarray. You need to find the smallest subarray starting at I such that bitwise OR of the subarray is equal to max of B of ik, where I less than equal to k less than equal to 1. Okay. Bitwise of or is the bitwise OR of all the numbers of it. Okay, written in integer. So we'll answer I, answer of size n, where answer I is the length of the minimum size subarray starting at I with maximum bitwise OR. Okay. A subarray is a contiguous non-empty subsequence. Okay. Okay, so what we can see, let us see the example. The example is 1. The example is 1 0 2 1 3, and for each I, so I would be 0 1 2 3 4. For each I, we have to identify what is the minimum size subarray that starts from I and has the greatest OR. So in the example, we can see that okay, the starting maximum bitwise OR starting at any index is 3. So starting at 0 index, the shortest subarray that yields it is 102. Okay. Starting at index 1, the shortest subarray that yields the maximum is 0 to 1. Okay. Starting at index 2, the shortest subarray that yields the maximum bitwise OR is 2 1. Okay. Starting at 3, the shortest subarray that yields the maximum bitwise OR is 1 3. Okay. 4, the shortest that yields the maximum is okay. So for each position, maybe I'll just leave this one empty. So for each position, we have to calculate the minimum size of subarray starting from that index which has max bitwise of OR. Okay. So one immediate thing that we can observe is that for the last index, the answer would always be 1, right? because we cannot have an empty array. So whatever the bitwise or so we will basically assume that the bitwise or of a single integer is the integer itself. So in this case, the bitwise or of 3 would be 3 and the answer would be 1. Okay. Now, if I look into it, for starting from 1 and 3, the answer will be at least 1, but it can be 2, it can be 3 as well. Okay. Now the thing is, I want bitwise OR. So one thing that I want to see is if I take bitwise OR of 2 integers, the answer is always greater than or equal to both the numbers. Is that true? So suppose I have any integer, let's say this is a bitwise some not, and I have some other let's say something like this. Now if we are taking bitwise OR, that means that wherever there is 1, in the answer there would always be 1. So in both the places, wherever there is a 1, in the answer we will get a 1. So 0, 1, 1, 1, 0, 1, 1. And that would mean that the bitwise OR of 2 integers is always greater than or equal to both the numbers. Yeah. So now yeah, now I just need to verify one other thing. So let us say that we have a number, let's say A, and we take its bitwise OR with B, and the answer is, let's say, X. And then we have a number A, we take its bitwise OR with, let's say, C, and the answer comes out to be Y. Now, can I claim that if B is greater than C, then X is greater than equal to Y? I think I can, yeah, right? Either it will be equal. So, and let's put one more condition, that A is less than B comma C, let's say. So if B is greater than C, that means that either the most significant bit of B is greater than C, or there is at least there is one bit, basically maybe B is something like this, C is also 100, but there will be one bit where B will actually be greater than C. So if we are doing OR, that would mean that X will have that bit set to 1, and we are assuming A is less than, let's say, this also. So the OR will guarantee that the first bit is set to 1. So we know that, okay, X will be greater than Y. Okay, so what does this result give us? What does this result tell us? This result tells us that just a minute. So this result tells us that um, the maximum bitwise OR will be obtained by having XOR with the maximum element in the subsequent array. Yeah. So what that means is that this problem transforms to finding the index of the next greater element, or maybe the next mm, mm, somewhat like the next greater element, but let's see. Um, but the next greater element with the most significant bit. Now, okay, so in this example, 1 and 2 basically making a OR gives 3. So the last 3 is of no use, right? So we want to find not only the greater element, but let's say if the last 3 had been 4, then the answer would have been 5 for this, right? So it is not the only next greater element. We have to find the element with the next greatest bit, right? So for example, or not the not next greatest bit, yeah. So basically the most significant bit, but let's say, will that also work always? No, right? Because if you have 1, 1, 0, 0, and let's say 1, 1, 0, right? In this case, the answer will be different. It will not be about the most significant bit. In this case, you also want to go to the end. Hmm. Okay, so how do we proceed? What is the absolute brute force? Right, absolute brute force is actually traversing through the array, maintaining the maximum value if you have a new maximum value updated, right? And that would be O of n square. So we are looking at O of n, or it would be O of n because we cannot really sort the array. So log n does not really have a way to pop up here. So O of n solution. And it looks like there can be some kind of stack approach here, right? This seems eerily similar to um, find the next greater element, but we it feels that we just have to modify the logic somehow. Okay, so let's take a case of 1 0 2 1 3 only. I'll write it on bits 1 0 1 0 1 1 1. Okay. So this is one, this is one. One zero two one three. Now, what information do I need to? Zero two one three. What is the inputs? case, I'll be coding the brute force approach first. Okay. So, what in the brute force approach, we are just given a different norms. Okay. Answer, and we also need dot size. This only we will push back. That's it. Okay, so the brute force is working, it seems. Let's try to submit it. Okay, so as I was expecting, so there should be the brute force is off and square. It is passing on 56 out of 59 test cases, but there needs to be some better method to solve this. So when I come to 1, what I will check is that okay, I mean myself 1 and the raw of maximum raw of all the elements excluding me to my right is 3. Okay. So will I be able to make a new contribution? It is 3. It is greater than myself. So it does not matter whether if it is 3 and it is greater than what I am, then it does not really matter. Right? If it is greater than what I am, yeah, so my or would be greater. Now, um, so the question is that should I go all the way? Should I pick all the places, or there is some way I can stop and retain? But let's say for this case, for this one, it's just above. It's enough. You take all of it. So the answer for you will be 3. And, size will be 2, or maybe instead of size, we will just take the next index. So for this will be 5, for this will be 5. I come to 2. 2 says that okay, starting with this index, the maximum size I know it goes to 5. Okay. So I am 2. And what is size? Size is also 3. Okay. So it is greater than me, right? Okay. Let us go on that thought process. Okay. Maximum size available is maximum method or difficult by research. So I will not consider any research here, but I don't think that is going to be useful there. It seems more like a stack block. can be used by someone. Let's type currency. Basically 10213 है इसमें. तो तुम क्या करोगे इसमें इंडेक्स से इंडेक्सिंग कर दोगे 3,4 है ना. ये तुमने लास्ट इंडेक्स डाल तुम बदलेगी ये वैल्यू है. तो हमेशा तुम्हें मैक्सिमम जोर वैल्यू या फिर कम जोर वैल्यूज रखनी है. बार वाली वैल्यू कोई पहले वाला यूज़ कर सकता है. पहले से जब तुम जोर पे आए तो मैंने कहा कि हाँ यार 1,3 है. तो जो टॉप पे जोर वैल्यू है, जो और वैल्यू है, वो जो वैल्यू और वैल्यू ऑन टॉप is actually or value on top is great. So this one will definitely have to use this value. अभी next element क्या है 1 और 3 है. तो yeah okay, so for this the answer is there. So I'll say this is already bigger. So if I also have 1 and this is 1 or value till now. Okay. If I or both of them, I will get answer as 3. No, this is not the or, this is the maximum element. see the topic. Array, binary search, bit manipulation, sliding window, company, remote concept. Okay, so you think about binary search now. And then, so what the hint is saying here, consider trying to solve the problem for each bit position. Okay. Okay. And given the hint, consider try solving the problem for each bit position separately. So let us just restart with the problem. Okay. So we are given 10213, and for each position we have to tell what is the minimum sub-array size where the vectorial order is not. Okay. Now let us see 10100. This is the Okay, let us try to take hints now. Hmm. Okay.